My dear students, in the previous class we have discussed what you are right now seeing in the object in the black in the board, and I told you that something was left in the previous class discussion, and finally we derived the lens maker formula, that was 1 by f is equal to mu 2 by mu 1 minus 1 by r1 minus 1 by r2. That was we derived in the previous class, and this is the lens maker formula. But there is a special cases, some special case in this particular derivation. I'm rubbing this part and I'm writing this here. Lens maker formula derivation is done. This is also very important topic for first second year physics. I hope you'll practice at home and you'll try to go through it. So as we found that the lens maker formula was stated like 1 by f is equal to mu 2 by mu 1 minus 1 whole into 1 by r1 minus r1 by r2. Now in this case, if I told you that this 1 by f came from the lens formula. As you know, the lens formula is 1 by f is equal to 1 by v minus 1 by u. But there is a logic also. That is for special case. For special case, means number one, if I consider that the object is at infinity, if we place the object at infinity, that means you can see this is the object, and right now this object has been kept at infinity. As you all of you know that if the object is at infinity, then image is formed at focus. You know it. If object is kept at infinity, then the image is formed at focus. This is the things you know, and image distance will be minus. Now if I put this value over this equation, then what I will find that I am bringing this equation here, that is 1 by v minus 1 by u is equal to mu 2 by mu 1 minus 1 whole into 1 by r1 minus 1 by r2. These things we found. Now in this case, I want to tell you that the image distance, this is the image distance and this is your object distance. Where the image was kept, object were kept at infinity, and image were found at the principal focus. So if I put the value now 1 by f minus 1 by infinity, u in the place of u it will be minus of infinity, is equal to mu 2 by mu 1 minus 1, that is 1 by r1 minus 1 by r2. So this implies we can write 1 by f, and 1 by minus infinity will give you 0 result. So is equal to mu 2 by mu 1 minus 1 whole into 1 by r1 minus 1 by r2. This is the lens maker formula. Special case when the object is at infinite distance. I hope you have understood these things. It's a very important concept, lens maker formula, that is related to the refraction at a spherical surface. First of all, you should know that in order to derive this particular derivation. Now we moving to another new topic today, that is power of lens. You kindly write the headlines before I write. That is, we have studied in class 10 in the chapter light, that is power of lens. What is power of lens? I'll write here power of lens. Power of lens. We know that there is two type of lens. One is convex lens, one is concave lens. What does convex lens do? Convex lens converges the ray of light or beam of light once it fall over it, and concave lens diverges. Am I clear? These basic things we have discussed in the very beginning of this particular chapter. So if I define the power of lens, you'll write it is defined as the ability. It is defined as the ability to converge or diverge. Converge or diverge a beam of light. A beam of light that which falls on it. That is the definitions of power of lens. This is very simple thing. It is defined as the ability to converge or diverge a beam of light. A beam of light which falls on it. That means once a beam of light or ray of light falls over a lens, then after falling, how much it can converges and how much it can diverges, that will be the power of a lens. And we know that power of a lens is related to the focus of the particular lens. And the power of a lens, and it is expressed as P is equal to 1 by F. That means we can say that power of a lens is what? Power of a lens is expressed as P is equal to 1 by F. That means it is dependable upon the principal focus of that particular lens. And it has got a unit. Its unit is diopter. Okay, diopter. Spelling, you please check it the spelling. I might be wrong in case of spelling. Its unit is diopter, and diopter is expressed as capital D. Understand? The unit of power of a lens is diopter, and which will be expressed as D. Am I clear? Now, as I told you that what will be the power in case of convex lens and what will be the power in case of convex lens. Hopefully, in case of convex lens, the power will be positive, and in case of concave lens, this will be negative. How this show? If I again go to the formula of lens maker, so what we found in the lens maker formula, finally, according to lens maker formula, we found that 1 by F is equal to mu 2 by mu 1 minus 1 whole into 1 by R1 minus 1 by R2. That was exactly what we found in case of by the lens maker formula. 1 by F is equal to mu 2 by mu 1 minus 1 by R1 minus 1 by R2. So this is the radius of the first spherical surface, and this is the radius of the second spherical surface. Now, as you know, for convex lens, for convex lens, the power of the lens will be positive, because if we take a convex lens, see, suppose if I am taking a convex lens over here, suppose this is a convex lens, that means this will have two surfaces. Am I clear? If I write the principal axis, this will have what? Two radius of curvature. This side one radius of curvature, and this spherical surface will have one radius of curvature. This spherical surface will have another radius of curvature. So in this case, if I consider that in this case what will happen, that R1 is equal to, in this case, R1 radius of curvature for the first spherical surface, that is going to be positive. Am I clear how it is going to be positive? Because radius of curvature is going to the right side, so it is going to be your positive. Is that clear? Similarly, in case of the second reflecting surface, if I see that in case of second reflecting surface, this is the reflecting surface, and this will be the radius of curvature. That means radius of curvature is going to be to the left side. So in case of R2, that is going to be your negative. Are you getting my point? What I am telling? That in this case, the radius of curvature for the first spherical surface is going to be your positive because it is right side. And for the second reflecting surface, radius of curvature will be considered as negative because it is the left side. Now if I put the value over here, that means R1 is going to be positive and here R2 is going to be negative. That means whole this result will become 1 by f into our power. So whole this result will become what? Positive. That means the focus power of the lens in case of convex lens will become positive. How I have just treated you. And you know that mu is always going to be what? More than 1. Mu is always going to be, if this mu is more than 1, so this is not going to be 0 or anything else. That means this result is going to be stay as positive. Is that clear? So in case of convex lens, the power of the lens will be positive. Now what about for concave lens? For concave lens, as you know, that if I make a convex lens like that, suppose this is a convex lens, and here also two spherical surface, you can say that in the case of first spherical surface there will be a radius of curvature, suppose R1 and suppose R2. So you can see that R1 in this case, this is the first spherical surface, R1 will be what? Negative. Am I clear? And R2 you can see this is the second spherical surface, so R2 is going to be this side, that is also going to be your this is going to be positive. Have you understood what I am telling? In case of the first spherical surface, radius of curvature will lie this side, that means left side, so it is going to be negative. In case of second spherical surface, it is going to be lie in the right side, hence it is positive. So if I put the value of R1 here, it is negative and this is positive, so whole the value is going to be minus. So in case of concave lens, the power of a lens will be negative. Remember these things. For convex it is positive, and for convex it is positive, and for concave it is negative. Is that clear? And I have told you diopter, that means diopter is the power SI unit or unit of the power of a lens. If somebody asks you what is 1 diopter, if the focal length of a lens is going to be 1 meter, if the focal length of a lens is going to be 1 meter, then the power of the lens is going to be 1 diopter. In case of convex lens, it is positive 1 diopter. In case of negative concave lens, it is going to be your minus 1 diopter. That thing remember. Am I clear? So this is all about power of a lens, that is dependable upon the focal length of a lens. And as you have given you that power of a lens is expressed as 1 by f, where P is the power and f is the focal length of that particular lens. So it was a very small topic. I hope you have understood it. You keep practicing, and in the next topic will come with, in the next video, that will be the power of a too thin lens in power in contact. If you contact to thin lens, then what will be their equivalent power, equivalent focal length, we'll find out in the next video. For today, thank you so much.